Today's video topic is dilations. This is our fourth of transformations, the fourth day of Standard 4, and we will be using IC15 for today's notes. So the introduction reminds us that when we're dealing with dilations, we might have reductions that are happening or enlargements. So if we look at our two images in each of these boxes, our goal is to identify which is the pre-image and then to compare the size of the pre-image to the image to decide what's happened as part of this dilation. So in this figure, triangle RST is the pre-image. We can tell because the image always has the primes attached to the letters. And so we're going from this shape to this one, which means the size of that shape is reducing, getting smaller. So that dilation would be a reduction. For the second and third, the opposite happens because our pre-image in both of these, the one without the primes, is the smaller figure. The image is growing and getting larger. So both the one in the middle here and the one at the edge is going to be enlargement happening. As we think about dilations in general, they're easy to spot because they're going to be transformations that change the size of the figure. And the way that that happens is by a scale factor as well as a center of dilation. All of the dilations that we'll do in class are going to happen using the origin. And so because of that, we're really just going to be multiplying all of our coordinates, both the x's and the y's, by the scale factor. And so what that will cause is either a reduction, like we talked about up above, if the figure is getting smaller, or it'll be an enlargement if the figure is getting larger or bigger. Reductions are going to happen if our scale factors are between 0 and 1. So fractions like 1/2 or decimals like 0.4 would cause reductions to happen. Enlargements are going to happen anytime our scale factor is bigger than 1. So if we're multiplying by 2 or we're multiplying by 2.5 or 3, those will cause our figures to grow and be larger than they were initially. Moving into some examples, we have a pre-image given to us for each of these first three as well as for number 4. And each time that pre-image is being asked to dilate, we've been given information about what n is equal to. That n is the scale factor we were talking about up above. And so that n is going to be our multiplier. So the easiest way to think about what's happening here is we're taking original points like A, B, and C, and then all of the x values and all of the y values are going to be multiplied by the scale factor to turn those three original pre-image points into new A prime, B prime, C prime image points. Now you could try to do all of that in your head, but that's a lot to keep track of. So that's why I made a list of A, B, and C, and then A prime, B prime, C prime. Once we get our prime points figured out for our image, we'll just graph them and we'll be able to see, hopefully, that a reduction has happened because that scale factor is equal to 1/2. And then we'll also notice a couple of other things once we get that information graphed. So first things first, let's think about what the coordinates are for A. So we're counting to the left, 3, 4, 5, 6 boxes, and then up 1, 2, 3, 4, 5, 6, 7, 8, 9, it looks like. So 6 to the left and 9 up would look like -6, 9 for that ordered pair. Just going to double check 3, 4, 5, 6, 7, 8, 9. Yep. And 1, 2, 3, 4, 5, 6. Okay. So if I take both of those and I multiply by 1/2, 1/2 of -6 will be -3, but 1/2 of 9 is going to be a 4.5. And so that means that when we graph A prime, we're still going to go 3 to the left and we're still going to go up, but we're going to be headed up 4.5 boxes, which means our A prime is going to land in the middle. of those grid marks instead of right directly at the corner like we're used to. All right, we're going to repeat for B, but this time B is 1 to the right, so that's a positive 1 for X. 1, 2, 3, 4, 5, 6 up for Y. So if we take our half and we multiply, half times 1, or half of 1, is just a half, or 0.5, and then half of 6 would be 3. So to graph our B prime, we're only going to move right half of a box, but still up a full 3. So again, we're not going to be exactly on those grid lines like we're used to. We're going to be kind of in between where 0 and 1 would be for X values. Last but not least, we're going to tackle point C. So that's 1, 2, 3, 4, 5, 6, 7 to the left, which is a negative 7 for X. 1, 2, 3, 4, 5 up, so 5 for Y. So both of these, when we multiply by that scale factor of a half, are going to be halves. Half of negative 7 is negative 3.5, and half of 5 is 2.5. So we're going to be counting 3 full boxes and then a half to the left, and then 2 full boxes and a half up. So that C prime point is going to be in the middle of a box, not even on a vertical grid line or a horizontal like the last ones, but just in the middle of that box completely. And then our A prime, B prime, C prime triangle can be connected together. And so we notice that each of these sides of the image are half the distance of the pre-image. That's what that scale factor of a half does. And then also these points are half the distance the original pre-image points were from the origin. So if we imagine how far away A was from the origin, A prime is only half as far. So it's pulling that shape back in closer to the origin because we're using the origin as the center of dilation. All right, number 2 is going to be a little bit easier because we're not multiplying by a fraction, so we shouldn't have to graph points that have any kind of decimals or fractions associated. I'm going to use my same process though. I'm going to think about my A, my B, my C, and then I'm going to use multiplication by 2 this time to find out the A prime, B prime, C prime values. So if we're thinking about A, I need to count to the left, 1, 2, 3, 4. So that'll be an A value of negative 4, or an X value, of negative 4. And then go up 1, 2, 3, 4. So a Y value of positive 4. I'm going to go ahead and take care of my multiplication right away. So negative 4 times 2 would be negative 8. Positive 4 times 2 would be positive 8. So right away I'm going to graph 8 to the left and 8 up. That's going to be where A prime should land. It's going to be twice as far away from the origin. Moving on to B, it looks like it's 3 to the right and 1 up, so a positive 3, positive 1. Multiplying both of those by our scale factor of 2 is going to turn B prime into 6, 2. So 6 to the right and 2 up mean that B prime is going to be twice as far away from the origin as it was originally. Instead of 3, 1, it's going to be 6, 2. Last but not least, we have C, and it looks like to get to C, I just need to move left 5, which means my y-coordinate is 0. So when I multiply by 2, negative 5 times 2 is negative 10. Be careful with 0. 0 times 2, or times anything, is still just 0. So that C prime point is going to be 10 to the left, but I don't move up or down at all. It's just going to stay right there on the x-axis, but twice as far away as what it was originally. So my image triangle this time looks like this: A prime, B prime, C prime. Got a little curvy on that last bottom side. Sorry about that. Try to draw that in nice and straight. I should have used a straight edge. So each of the sides this time of the image are twice as long as they were in the pre-image because of that scale factor equal to 2. Now number 3, I'm noticing that my scale factor is 3/4. So this is going to take some careful multiplication I'm going to use my same process to get my lists all set up for A, B, and C. And then when I multiply by 3/4, that's going to tell me my A prime, my B prime, and my C prime. X first, Y second, just to remind myself. And it might be helpful this time around to have a calculator, especially if you're not sure you remember how to multiply by fractions very well. Different calculators deal with fractions different ways. So I'll kind of go through some options with that as we're going through this problem. Go ahead and pause the video and fill in what the A, the B, and the C points are though, and then I'll meet you back here to talk about the dilation. Okay, I filled in my A, B, and C coordinates, so just double check those with yours very quickly. And next order of business is to multiply each of these by 3/4. Anytime we multiply 1 by a number, we just get that number back. But because we want to practice using the calculator, I'm going to go ahead and run through that process just so that we can see it. If you have a calculator like this one, there's actually a fraction button that you can use. So if you click that button, you can type 3/4 in so that it looks like a fraction, and then we're just going to multiply that by 1 because that's our coordinate. If you don't want to leave your answer in fraction form, there's a double arrow button down here at the bottom. If you click that right away, then it will give you the decimal form of that fraction if you prefer that. So 0.75 is going to be the x value for A prime. And then what's nice about this calculator is that you can go up and you can highlight that original multiplication problem, and we can just swap out our x value of 1 for the next thing that we need to multiply. In this case, it's a 4. So then I click enter and it tells me what my y value is. I can go and select that by arrowing up and highlighting it again, and I can just keep right on putting in my new values. So 3/4 times 8 is going to give me 6, and so on and so forth. Now, if you don't have that calculator, it's going to look a little bit different on some of our other calculators, so I want to make sure that you know how to handle that. The easiest way on other calculators to deal with this is to just type this fraction in as a division problem. And if you want to be kind of careful about it, you could put it in parentheses. So 3/4 times, the one that we're up to next is a y value of 1, so I'm going to go ahead and multiply by 1 again. And that's going to just automatically send out that 0.75. It won't display your answer in terms of fractions, but that's okay. Decimals are fine. And then this one is a little bit trickier to just go up and edit, because if I arrow up, my answer will disappear, but then I can just go ahead and arrow over and replace whatever that y value was, in this case, that I had there, with whatever my next value is. Now this is a little silly to type in because anything times 0 is just 0, but if we're practicing using the calculator, we can just keep doing that, arrow up, arrow over, you change that to be whatever it needed to be if it was different. But in this case, that last y value we have is still just 0, so that will stay 0, 0. So you don't have to multiply by fractions on your own mentally. You can go ahead and use a calculator to help you with that. Once we get that taken care of, this is going to be a little tricky to graph. 0.75, when the boxes are so small, is going to look like more than halfway to a 1, but not quite all the way. So just do your best to eyeball that. Make it look like it's more than halfway. It's also going to be really close to that side of the triangle, so just try to be obvious where you're graphing it, kind of make that dot so that it's visible, and then label that with an A prime. B prime, we're going to count 6 to the right for positive 6. 1, 2, 3, 4, 5, 6. And then we're going to go up 3/4 of the way to a 1, or to 0.75. So again, it's going to kind of look like it's on the side of that original pre-image triangle. And then C prime didn't move. So this corner right here can just get relabeled as C prime. And when we connect those figures, it doesn't look like a whole lot has changed, but it has slightly shrunken back to make a slightly smaller triangle. Each side is 3/4 of what it used to be. And then this side gets to be slightly closer to the origin because of that 3/4 distance instead of the original pre-image distance. Okay, I'm going to have you go ahead and pause a second time. Go ahead and list out your points for L, M, and P, and then go ahead and multiply by that scale factor of 3 and see if you can do this one on your own before you come back and press play to check your answers. Okay, sometimes this one causes some issues because there's a lot of negative numbers that are popping up on this problem. So really double check your original ordered pairs. Every x and y value is negative for L, M, and P except for the y value on L. That's the only time you're moving in a positive direction for that pre-image triangle. So that means all of our x values when we multiply by 3 will still be negative, and 2 out of our 3 y values will still be negative. So just double check all of those. If you end up leaving off a negative, it ends up throwing a point to the opposite side of the graph, and it ends up looking like a completely different triangle than your pre-image. So it's usually pretty obvious if you've forgotten a negative sign, but it's also kind of irritating to have to regraph and change that. So always good to be careful about those from the beginning. So what's happened in this one is all of these points are triple the distance away from the origin, but that also means that each of our sides is 3 times as long. MP is the easiest one to look at. That has a distance of 2, but when we graph M prime, P prime, it has a distance of 6. So that side is 3 times as long as the pre-image side, and also 3 times farther away from the origin for each of those vertices. All right, number 5 is the example of the level 4 question. If it was a dilation question, we are starting with a pre-image that's small and we're ending with an image that's big. So somehow we need to figure out what kind of dilation has happened by recreating that scale factor. So what I like to do is compare pre-image image pairs. So when I look at L, it's 2 to the left and 1 down. That's -2, -1 as an ordered pair. But L prime is 4 to the left and 2 down. So to me, I'm feeling like this is multiplying by 2. -2 times 2 is -4. -1 times 2 is -2. So chances are this is going to be a dilation about the origin, because we always include that as our center, using or with n equal to 2. But I'm going to do a quick double check with one more pre-image image pair just to make sure. So if I look at P, that's 4 down, so that would be the point 0, -4. If I test out my dilation, 0 times 2 would still be 0, -4 times 2 would be -8. So let's see if that's where P prime lands. 0, -8 would be down 8. 5, 6, 7, 8, and sure enough, that's exactly where they have P prime graphed. So that makes me look pretty good, or feel pretty good about that particular description for the transformation that's changed the pre-image into the image. So if we do a quick summary like we have for all the others, does a dilation change the size of the pre-image? Yes, this is actually the first time the size of the pre-image has been changed. This is a little tricky to answer. Does it change the shape of the pre-image? And the answer to that is actually no. It's just an enlarged or a reduced version, but it's the same type of triangle that it was originally. We'll deal with that a little bit more second semester. We'll talk about what we call triangles that are just larger or smaller versions of each other in terms of more than just a dilation, being more specific about what that's called. But for right now, it does change the size of the pre-image. It doesn't really change the shape, but it does also change the location because that triangle is either farther away from the origin when n is bigger than 1, or it's closer to the origin like we saw up in number 1 and 3 when n is between 0 and 1. All right, that's it for dilations. Hopefully that makes sense. Come back tomorrow with questions if you've got them. Thanks.